All right, cool. Okay, so my name is Bob. For those of you who have not met me, I am the principal of Mastery Analytics, and I want to talk to you guys about Hadoop. When I was putting this presentation together, I realized that there are actually a lot of YouTube presentations on this exact same topic. So instead of just talking about the software, I want to actually make the business case for Hadoop and try to convince you guys to actually use Hadoop instead of what it is you're already doing. If you have any questions, go ahead and pop off right there. We'll handle it right there. There's not going to be a formal Q&A at the end. If you have a question later in this week, you can go ahead and email me at bob@mastery.net. If you want to learn a little bit more about what we're talking about today, you can follow me on Twitter. My Twitter account is pure data. There's no cat videos or ALS bucket challenges on there or any stuff like that. So, all right. No, it's been done. It's been done. Okay, so who is Mastery? I am Mastery. I've been contracting for like 3 years straight, and one day I woke up recently and said, "All right, let's just go ahead and make it official." And I formed an actual, formal legal entity. But here's the thing: the reason why I have been able to go ahead and contract for like 3 years straight is because so much opportunities out there right now to the point where I can't handle it by myself. So I'm actually looking for partners. If you love data as much as I do, and you've reached a point in your career, you're ready to step out and do your own thing, then please come find me. Let's trade cards. Let's go to lunch, and we'll talk about it. So, all right, enough about me. I've got two objectives for this evening. Okay. The second objective is the most important, okay? Because what I'm really trying to do is I'm trying to create jobs. And this is a little weird considering that Matt started off this presentation by saying that a lot of people are hiring right now. But I think that a lot of reason that people do not use Hadoop right now is because they don't really understand what it is and what actually you can do with it. And so I can't go around to all of Kansas City and tell people that. I need you to help me spread the word. So if you can do that, I would much appreciate that. Okay. So who was here the last time I spoke? 1, 2, 3 people. Okay, so not very many. All right. So last time I was here, I was talking about MongoDB and NoSQL and the NoSQL movement, right? And I basically painted up this picture of what NoSQL was going to do to our career field in terms of the disruption, right? And so I painted a picture that kind of looks something like this, right? Can you even see that very well? Here's a wave. This is like really bad up here. It looks better on my laptop, right? And so I even said the terms like, okay, here comes the wave, here comes the NoSQL wave. You can either surf it or drown, right? When I was preparing the next presentation I was going to do this evening, when I was going to teach you guys how to actually do analytics out of MongoDB using NoSQL techniques, I tripped across Hadoop. Okay, and from that, I started studying Hadoop, and I realized that the combination of Hadoop plus NoSQL plus cloud, actually the level of disruption is not this. It actually looks something a little bit like that. So when I realized that, I figured, okay, let's take a step back. Let's take a look at the whole picture, the whole ecosystem. Let's master that first, and then we'll go forward. Next time, I'll bring some code, I promise. Asterisk, it might be Java. Talk about that later. Okay, so when we all get together like this and we talk about some of the things that we talk about and the awesomeness that is big data and some of the things that you can do with the algorithms that are out there, right? We make big data sound really cool. We make data science sound really cool. We've got our meetups and we've got our hackathons and we've got the big data KC that's coming up here in November. When we're all together, it's like fantastic. We make it sound like something like this, right? Like the future is now. We show up to work, we put our car in a suitcase, we go in and push a button all day, okay? Matt has a job like this. Pierre has a job like this. I don't have a job like this, okay? My job currently is helping somebody move their data off a mainframe system into SQL Server. So at best, all we're going to be able to accomplish is to just get them to one generation behind the current state of the art, right? So based on that experience and based on some other things I've taken a look at, as an example, Gartner put out a research note recently that said that only 1 in 8 organizations are actually taking advantage of big data, and I think that's kind of optimistic. It's probably more like 1 in 20. And just today, I read another note that said somebody had put out a survey for executives, and of the respondents, they said that while they were interested in big data, nobody had any plans to actually do a big data project next year, which is like nuts to me, right? And so the reality is, while some people may be working like this, the grand majority of us tomorrow are going to go to work like this. This is unfortunate, right? Because what this actually means, despite what Matt said earlier about the jobs that are hiring, what it means is that there's actually very few places that we can actually go and apply our trade at, right? And the reason for that is because the ecosystem is not set up for us to really do our job precisely. Now, I keep saying us. I know there's like very few people that are actually working as data scientists, but if you think of it from the standpoint of somebody that's actually wanting to break into the career field, they're going to be competing against guys like Matt and Piero for jobs that there's just not that many, right? So what we need to do is we need to crack the career field open just a little bit more than what it's already at. I know it seems great here, but if you think about the jobs that are available in Kansas City versus who's hiring data scientists in Lawrence versus who's hiring data science in like Fort Scott, Kansas, we're not as ubiquitous as like an accountant, right? And I think we can probably get it to that point. Moving on. And obviously, if you should take a look at Hadoop, right? I have developed some red flags that you guys can use to evaluate whether you should probably be doing something different with your current workflow in terms of what you're doing with data right now, right? These next couple of slides are a lot more funny if you read them in Jeff Foxworthy's voice. You have to make it. No, I'm not gonna read it. So there's a cost, right? There's a cost to storing data, and it's not just a dollar cents cost. There's actually a cost and an impact to your analysis, right? If you have so much data that you can't economically store it, you've got some options. You can send it to tape, you can delete it, you can crunch it up, aggregate it, and then just store it aggregate, which will give you a percentage of what you originally had. All of those options mean that you now have less data or even no data than what you had before, right? The cost of that is that there might have been a nugget piece of information in that data that is no longer in your analysis because it's out of your ecosystem. What Hadoop does, it allows you to take some of that data that you could not store beforehand, bring it back in so you can do a more full analysis. Another flag here. This is a hot button for me, right? So who's ever dealt with this? You walk in, it's in the morning, 8 o'clock, you grab a cup of coffee, you sit down at your desk, and there's like 8 different emails from executives saying his report no longer works. You go look at the report, it's not working. You go look at the ETL that runs the report, you realize it's not working. You have to find the bug in the ETL. Pretty soon it's like 5 days later before the guy's report's working, right? Like that's not our job. Our job is to get numbers out to people to where they're useful, not be working on ETL. Okay? Hadoop gets rid of a lot of the clunky ETL processes that you have in the old school system way of storing things data in relational warehouses, storing data in relational warehouses. Okay. Another flag, real-time analytics. This is really difficult to do in the old world, right? I had a client once where their solution to real-time was to load the warehouse every 15 minutes. The problem was that their warehouse load process was not robust. So what we really wound up with was every 15 minutes something breaking like every single day. And so our job basically became fixing the warehouse load as opposed to actually doing analytics. Hadoop, again, gets rid of all that. It provides some tools for you to actually do real time in a manner that actually makes sense to the point where it's not 15 minutes. It's like 1 minute. Now we'll talk about that like a little bit later. Okay. Another flag. So you've been working in relational databases for years like I have, right? All of a sudden the programmers come to you and say, hey, we're going to kick out a JSON to you. You got to parse this JSON and put it in the warehouse. And you're sitting there like, hey, what's a JSON? Two, how do I I mean, I'm not used to parsing things. Are you kidding me? Oh, I know what I'll do. I'll just take this JSON object and just shove it into one column in complete and total violation of first normal form. I've seen that is what we do. Okay, don't gotta do that. There's tools that you can handle JSON objects with just naturally, right? Because JSON and Hadoop plus NoSQL that just all works together seamlessly. Okay. If you're thinking about doing a data warehouse project, if you're in an organization that's thinking about doing a project from scratch, for the love of all that is holy, stop. STAPH, stop. Think about Hadoop first before you go down that path. I guarantee you, you'll probably save a lot of money going down the Hadoop path as opposed to trying to do things in the old world. Here's a big one, okay? And can you see the bottom here? Okay, well you can see the numbers, right? Okay, so I got these numbers from a guy named Satosh, who is the VP of a company called AppFluent, right? So we talked earlier about the cost of storing data in terms of the impact to your analysis. Now we can actually talk about the actual dollars and cents cost, right? And so you can see the big huge difference between the old world and the new world, the cost of actually storing data per terabytes. When I take a look at this, I don't even understand why somebody would not use Hadoop in their organization at this point, right? So if you switch to Hadoop, you've got really 2 options here. You can spend what you're already spending and get 13 times more storage, or you can just reduce your cost of storage and get your storage space down to whatever's appropriate to you, right? So really big reason right there to just use Hadoop just based on the dollars and cents argument. Okay, who's dealt with this situation before? You're running some sort of situation. I think Pro just talked about this. You're running some sort of analysis. It might be a clustering. You're running it on your laptop or whatever, and all of a sudden you run out of memory. what do? Okay? Well, you go out to the server. Like what you say, you're using like a almost a microcomputer or supercomputer or something like that. Go get a bigger machine. Go spin up an AWS instance. Use Google Big Table. Just more RAM, more hard drive space. Hadoop says no. Don't do that. Instead of going out and get a bigger, beefier, more expensive machine, go out and get a bunch of cheaper machines, string them all together, and then do your analysis that way. Okay, so what does Hadoop? We're on slide 20. I guess I can probably go ahead and answer this question. Okay. I'm probably overselling this first bullet point. The thing is that for all the problems that I've been dealing with for the past 3 years, the persistent problems, the problems that follow me everywhere, the problems that make me grind my teeth, they're just solved by Hadoop, and they're solved elegantly as well, right? To the point where it doesn't hardly even take any work to fix the things that I have been struggling with. I was talking with an executive recently, and he made the comment to me. He said, "We're probably not going to use Hadoop because this stuff is so new." I didn't have an answer for him at the time because I'd only been looking at Hadoop for about 2 weeks. The reality is when I started digging into it, I realized that Hadoop is actually fairly old. The technology that Hadoop runs on, it's like 10 to 8 years old, depending on what you're actually looking at. Okay? What this actually means is that how should I put this? Here's a better way to take a look at it, right? So that comment, okay, well, this stuff is all new. This stuff is not new. Think of it as this stuff is starting to become relevant, right? And so since it's relevant, a spotlight is being thrown on it. Back in the day when all this stuff was created, big data, quote unquote, was the problem of Yahoo. It was the problem of Google. It was the problem of Facebook. But now that we're staring down the Internet of Things, big data is like everybody's problem. And the solution to deal with it is Hadoop. So just by logic, Hadoop is for everybody, right? And there's another reason why I wrote this bullet point. Since Hadoop has been around for so long, it's actually gotten to a point where a guy like me who's more business oriented than he is technical, I could get my arms around it. It's open source technology, right? And so open source technology is usually pretty nerdy. It's like all command line. It's not like that anymore. It's pretty easy to work with, and there's a lot of GUIs per step. So really, it's gonna come to a point where your grandma can use Hadoop. When it gets to that point, everybody's gonna be using Hadoop. So you don't want to be left out of this, right? So Hadoop is one of those words that you have to be careful when you're talking about it, because it's one of those words that means different things depending upon what you're talking about, right? So context matters. So when you're talking about Hadoop, it could mean the software project, the Apache software project, Hadoop itself. It could be the software that's actually in the project. It could also mean one particular piece of software in the project, and it's so confusing that you could be talking to somebody about Hadoop, and you could be curious as to whether you're actually talking about Hadoop. So it's something that you have to watch, right? So yeah, yes, exactly. Not kidding, right? So if as we go along here, if I say Hadoop and you don't know exactly what I'm talking about, just pop your hand up and we'll deal with it. I'll clarify, right? So, all right, 2 key points to this slide. What are we really talking about right now? We're talking about distributed computing. Time check. Okay. We're talking about distributed computing. That shouldn't be weird. Astrophysicists have been using distributed computing for years to solve their problems. What Hadoop does is it puts distributed computing down on a lower shelf where the rest of us can get at it, right? The other key point is linear scalability. What linear scalability says is that if you have data that you're working on, okay, you've got X data. Processing X data should take Y resources. So if you've got 2x data, processing that data should be 2y resources, not 4y or 6y as it would take probably in the old world of doing things, right? So you think you want to talk to your boss about this stuff, okay? Take a lesson from me. Same conversation, the guy that asked me, that made the comment about, okay, well, this stuff is really old. Later in the day, I wound up talking to his boss, the CEO of the organization, and he asked a fair question, what is Hadoop? And at that time, again, I was only looking at this stuff for about 2 weeks, and I gave a decent explanation of what Hadoop is, but at the end of my explanation, he looked at me and goes, okay. I looked at him like, did you not understand what I just said? No, he didn't understand what I just said because I used our language, right? And so when I went home, I thought about that conversation. All right, how could I explain to an executive better about what Hadoop is? And I burnt it down to its essence, and I realized there's really only 2 things you need to talk about when you're talking about Hadoop. And you're talking about it to an executive, somebody that does not have our background, right? And so these are those 2 things. That's it. If you are talking about anything else besides these 2 issues, you're saying too much. Okay, the person that you're talking to, their eyes are going to glass over, and it gets awkward. Right. So let's dig into these things a little bit deeper, right? So Hadoop makes money. Reason number one. There are a group of companies right now that are using the software in the Hadoop ecosystem to actually create entrepreneurial firms. Not a firm like Mass Street, which is a consulting firm. They're actually creating new products out in the marketplace. One example of this is a company called Loggly. What they are is an in the cloud logging provider. What they do is that their clients point their logs, whatever they've got logging, their applications, their emails, whatever, they point it at Loggly's cloud servers. Loggly will use a technology called Kafka and Storm to suck up those logs, punch those logs, and then present them back to the user in a meaningful way. And I think they do that with like a dashboard or something like that. So that's one example. If you currently work in an organization that's not entrepreneurial, that's been around for a while, like I have, like I think the place that I'm working at now has been around for like 80 years or something, okay? It's still possible to generate a new source of data with your revenue. There is one company in town that is already doing this. I won't say what their name is, but they're taking a look at selling their data, right? Because they see value. They think that their clients will also see value in what they're storing. They talk to me about what they want to do, and they're going to try to do it without Hadoop. Um, it'll be interesting to see if they pull it off. What they're planning will be a heck of a lot easier with Hadoop, right? So think about the second bullet point for a second, right? A lot of us work in IT, we're working back at the house, right? We're a cost. With this second bullet point, with Hadoop, you actually become a source of revenue, right? Instead of a cost. And it's been kind of my experience that when you turn into a rainmaker, that tends to be career enhancing instead of being the guy that's constantly going, hey, can I have money for this? Can I have money for that? And when you turn around and go, hey, I'm going to give you money. Oh, suddenly a whole world opens up. Okay. Third bullet point, even if you're not doing one or two, there's still opportunities to make money with Hadoop, right? The things that we talk about, the whiz-bang things, the things that you see in the media, right? They are a lot easier. In some cases, they're practically impossible if you do them in the old world, and they're only possible if you use Hadoop. I had an example for this, but it's gone now. But looking at the time, I need to go ahead and move on. Okay, we've already talked about this. I'll just go ahead and hammer the point home. Storing data in Hadoop is a lot less expensive than doing it in the old world, right? Okay, so if you want to go take a look at this stuff for yourself, and you do what I did, and you do not have my level of intestinal fortitude, it's entirely possible that you could take a look at Hadoop and then run away screaming. Because what I did was I went out to the Apache website for Hadoop, and this is what I found: an absolutely dizzying array of software and projects and frameworks. I mean, it was insane, right? But it was actually kind of cool because I realized that all of these projects were built on top of Hadoop to solve some sort of shortcoming for Hadoop. So what you actually wind up with is a bunch of building blocks that you can piece together, you can pick and choose to put together for an optimal solution for whatever use case that you've got currently. We're not going to take a look at all these projects. We don't have time. I mean, I can see the clock. We're already 20 minutes into this. We're only going to talk about those things that are relevant to data science and doing analysis. Okay, I'm gonna skip these. Okay, and these next couple of slides I'm going to go through really quickly because for our purposes here they're going to be TMI, right? And so there's something called Hadoop Core. There's the core set of software that you need to actually run a basic Hadoop cluster, right? The first one is HDFS, the Hadoop Distributed File System. HDFS is the thing that keeps watch on everything, right? So Hadoop is a master-slave architecture. And Hadoop, HDFS is the thing that keeps track of all the nodes, makes sure the nodes are up and running, and keeps track of all the data and knows where all the data is at. Okay, and how it does that is that, so it's called the data operating system, right? Which shouldn't be confused with an actual operating system because HDFS actually does not take over your hard drive. What it looks like is a directory on your hard drive. You drop data into that directory, and then HDFS grabs it, cuts it up, duplicates it at least 3 times by default, and then spreads it out to all the computers on the cluster in a manner such that should you lose a node or a rack or something like that, that data is still available on the rest of the cluster. Every computer in your cluster is a node of some sort, right? So the master node is called a name node. When we talk about commodity machines, you want your data nodes to be commodity, but your name node needs to be beefy because it does all this work basically in memory, right? So your name node needs to be pretty tough. Your data node is the place where all your data is stored at. There are a bunch of other nodes that we're not going to talk about, just know that they exist and they all do stuff to keep everything running the way it's supposed to run. MapReduce. I almost don't even want to talk about MapReduce. MapReduce is what the 8-track was to us 80s kids. You might be aware of it, but you probably won't ever use it or actually own one, right? And so this is what Google uses to index the web. used to, right? When all this stuff was created like 10 years ago. This is the way that you interact with the data out on HDFS, or it used to be the way that you do that. Okay, to save my sanity, I'm going to talk in the present tense. MapReduce is the way that you interact with data out in HDFS, right? And so this is batch processing, and it's slow, and MapReduce has kind of gotten long in the tooth, and there are replacements for MapReduce. And instead of trying to explain how MapReduce works, I'm just going to roll forward. If I'm going over stuff real fast, don't worry. There's plenty of stuff out there on the web about all this. You can go back and explore it at your own speed, right? And so here's an important piece of software, Yarn, right? This is the third piece of software that's considered Hadoop core. There's only three, just MapReduce, HDFS, and Yarn, right? And so in the old world, MapReduce and HDFS were very tightly coupled. In the new world, you can take other applications and do analysis off HDFS, and the thing that lets you do that is called Yarn. I'm not going to bore you with the details of how that works. If you're stepping into Hadoop now, you'll probably never even know MapReduce. Yarn's just going to be your reality, because that's what Hadoop is now. Tez. Tez is a replacement for MapReduce, right? And so as you can see in this graphic down here on the right, or on your right, MapReduce is completely gone, right? And so if we want to interact with data in HDFS, there's programs that we can use. One of them is called Hive, another is called Pig. We'll talk about Hive here in a second. But if you want to interact with data on HDFS, you can use practically anything you want, plug it into Yarn, and then Yarn will do the work of talking to Tez, and Tez is the thing that actually does the data interaction that used to be MapReduce, and then it just flows down to HDFS, back up through Yarn, and back up through Tez. A lot of stuff in Hadoop you're going to learn is an abstraction. It's designed to make things easier for people who may not be that technical, and so what you wind up with is abstraction on top of abstraction. So we got Yarn is one abstraction, Tez is another abstraction, and Hive is yet another abstraction, right? So here's where we start talking about data analysis. If you are somebody that works in a warehouse or somebody that knows SQL, this is going to be the project that you're interested in, right? If you work with like SQL Server, like I work with SQL Server, right? So I use SQL Server Management Studio to get data in and out of SQL Server. You know, I can create tables, I can pull up data, etc., using SQL. Hive has a language called Hive Query Language that kind of looks like SQL, right? And so if you just picture whatever tool that you use to interact with your database, Hive is the tool that you use to interact with data on HDFS that provides a level of abstraction so you don't have to write MapReduce jobs or write Tez jobs, right? Hive will take your query language, turn it into a Tez job or a MapReduce job, and then that's how you that's an easier way to work with it, right? This would make more sense, I think, if I would have actually brought like a cold example. So just doing it by just with my hands, like a piece of code for Hive would be like this, and a piece of code for like MapReduce would be like this, right? MapReduce is like very, very detailed. It's almost like the difference between Java and like C. Okay, Cassandra and HBase, right? These are both column family NoSQL databases. Don't really have time to go into what a column family database actually is. I'm bringing these things up because they help me actually solve a problem. The thing with Hadoop is that it makes your data immutable. And what I mean by that is that you can't go in and do row level deletes to your data that's stored on HDFS, right? And so that presents a problem for me because a frequent thing that I have to deal with is that the transactional system or wherever that I'm ingesting data from, it may have errors. It might have human generated errors. It might have software generated errors, right? But I don't want that in my data ecosystem. And I know there's arguments for keeping bad data in your ecosystem, but my philosophy is that if it's not supposed to exist in the first place, I don't want it in there at all. But I can't blow away things at a row level if it's just in HDFS. I talk with a lot of people about this, and the solution to the problem is that you take data, you stick it in HBase or Cassandra first, and then that way you get back your row level deletes, and you can actually clean your data up that way. Okay. Now we're going to talk about some cool stuff, right? Up to this point, we've talked about how to solve old problems in new ways. Now we're going to talk about how to solve new problems in new ways. In order to do that, I need to talk about this concept first, right? And so the OODA loop is it's a decision-making model that was created by a fighter pilot a couple of decades ago. Okay? He created this model to teach fighter pilots how to kill other fighter pilots, but it's still applicable to business because what is business is just a dogfight without a lethal outcome, right? So observe, orient, decide, act. We help organizations move through this decision cycle, right? And so the point of this of what the guy that invented this was saying is that the guy that wins the fight is the guy that moves through this cycle quicker. So how do we move through the cycles quicker? with real-time analytics, right? And so now we can start talking about the things that he was saying that people think is cool, right? There are two projects and one abstraction that help you actually do real-time analytics in the real world. Kafka, Storm, and then Trident is an abstraction on top of Storm, right? Kafka is a messaging system. If you are familiar with RabbitMQ or anything like that, it's just basically a pub/sub messaging system that helps you ingest streams of data. So I'm enrolled in Rockhurst's data science program, right? And one of the things that we do in class when we're like working with models and whatnot is that we'll go out to Twitter and suck down a block of tweets and then work with them that way. What this allows you to do is instead of sucking down a block of tweets, you can suck them in a stream. Like basically, you can hook up to the Twitter fire hose using this, right? And then Kafka is a thing that helps manage those messages coming in, right? What Kafka does is it provides a level of less fragility to the system, right? Now, that's not the word that I'm looking for, but robustness. I'm sorry, that's the word I was looking for. It provides a level of robustness to your stream processing, right? So Storm is the thing that you're actually going to use to crunch all this data that's coming in. So a good explanation of these two things is that Kafka is like the waiting room and Storm is the hospital, basically, right? Stuff queues up in Kafka to be worked on by Storm. The guy that created this created something called the Lambda architecture. The Lambda architecture is what you design when you want to do any kind of real-time processing, and what that looks like is this. So basically, you've got three different layers, right? You've got your batch layer, and the overall concept here is that we want to analyze the deep past. We want to take our deep past analysis. We want to add that in with the recent past. We're going to combine those two batch views together and create one view at the end that analysts can then work from, right? So imagine, I was at a talk last week with a bunch of Cerner engineers, and they've got something that's set up like this. What they said was that from the time data comes in on this end and pops out the back end is ready for analysis is 1 minute. Now, I think that's cool compared to like what 1 day or 2 day lag that you find at like most organizations, right? And so this is the generalized case of the Lambda architecture. Here's a more specific case of how Lambda architecture actually works, right? This is a brand new slide. I can't quite talk too much about this, but here's what's going on basically, right? So here's our batch layer up here. Up top, we suck stuff in through Storm. We stuff it in a NoSQL database. We've got a batch job over here that actually crunches the data. Over here, this is where we actually are going to do our model, right? There was a disappointment with Storm. You can't really do streaming machine learning with Storm, and we'll talk about that in just a second. But what you can do is that you can create a model in Storm and then in real time update the parameters to that model, right? And so over here, we're creating the model. We create model parameters. Those kick out to R right here, and that actually, in conjunction with DynamoDB, serves up whatever prediction that they're trying to do there, right? And so this might actually solve some of the issues that he was talking about earlier in terms of how to do things more effectively in a real time process. Are either of you working with any of this right now? Okay. Okay. It's interesting that you guys are thinking about R. When I said when I come back and if Matt lets me talk again, that's probably going to be coming back with some Java code. You can do this stuff, all the stuff that we've talked about. You can use whatever language you want as long as it supports the standard in and standard out. So if you're an R user, if you're a Python user, you can write Storm code, you can write MapReduce jobs in all of those languages. The thing of it is that when we're talking about real time, we need speed. And just my particular opinion, I don't think that interpreted scripting language like Python or R will be up to the task as well as like Java. I could be wrong. That's just my understanding at this point, right? So hang with me. I'm almost done. Okay. I went over stuff really quickly. There are a lot of things that we didn't talk about that you're also going to want to learn that will probably be of interest to you that we don't have time to talk about today. I just want to go ahead and point them out. Scoop is an ETL tool. That's the tool that helps you get data into and out of HDFS back and forth between a relational database system. Pig is a data wrangling tool. I think the actual buzzword is data flow language. Here's the use case for Pig. If you've got data in HDFS. Data in HDFS is just files, right? It's just bytes. It's just files. If you have like a customer file and you have like a finance file, you need to bump those two files together, matching on some customer number or something like that. Pig is the thing that you would do it with. Drill. Okay, so earlier we talked about Hive. Hive gets you SQL-esque language. Drill is like Hive, but it's actually legit SQL. Like that was the point of that whole project. Number one. Also, Hive runs a little bit slow. Drill's a heck of a lot faster. I just discovered Drill in the past week, and I've been on this stuff for like 2 days, or excuse me, 2 months. That's one of the challenges with dealing with this stuff is that it moves really, really fast, right? And so um, the number of projects that are going on, the number of development, you really got to stay on top of it to know what's really going on. Okay, Mahal, a machine learning library in Java, right? So instead of doing machine learning in R or Python, you can use Java. Mahal's the class library you use to do that. Case catalog, it's another abstraction. I'm not going to get into that. If you have questions about H catalog, just email me. Samoa, this is what I really want to talk about, right? So I said earlier that Storm um, will not let you do machine learning in real time. That's my current understanding of how Storm works, right? uh, I think the reason for that is that the work that's involved with actually creating a model, right? And so these guys talked about all the work beforehand and that stuff. Um, Samoa is a set of algorithms that are designed for real time, right? So the algorithms that you and I might be familiar with currently, they have to be tweaked and rewritten just a little bit for processing streaming data. And Samoa is the project that lets you do that. So, if you want to get started with this stuff, you got a couple of options. You can go out to a company called Hortonworks and download something called the Sandbox. What that is a Hadoop cluster that runs in a virtual machine. You can run it on Windows. You want to learn some stuff, you just go out to YouTube. Practically this entire presentation came from like papers and YouTube. Um, Elastic MapReduce. I have no idea why they call it this. It should be called Elastic Hadoop, but Elastic MapReduce is a service by Amazon. You can go out to AWS. You can basically spin up a Hadoop cluster and play with it. The only problem with that is that it's pay for play, right? And I'm so into this stuff that it was worth it for me to just go ahead and build a cluster at home. But if you want to get started, there's a place to go ahead and do it out. Final thing, there's a new meetup going on in town, Kansas City Data Engineering at Scale meetup. This kind of I think, this is my opinion, this meets a gap between this group and the big data group. If you want to learn about how to actually build real-time systems and how to work with Hadoop and actually build Hadoop ecosystems, here's where you're probably going to go. Our next meetup is going to be, I think, the third Thursday of September. We meet at a place called Penton, which is about the 95th and Metcalf area. And I think that's all. Okay, well, these are things I might talk about next time, but Matt lets me come back, and I have gone way over time, so I'm just going to go ahead and wrap it up. Are there any final questions? Nope. Great. Excellent. Thank you for your attention.